Chapter 2, Section 1, Solving First-Degree Equations. Solving equations refers to the process of finding the number that makes an algebraic equation a true numerical expression or statement. For example, if we have an equation that says x minus 2 equals 6, then when we solve this equation, we should know what x is. So solving an equation basically is trying to figure out the number that we can plug in for a variable to make this statement true. So in this equation, it's pretty simple. So we know that x minus 2 equals 6. We should know that x is going to be 8. 8 minus 2 equals 6. But what we're going to do is we're going to figure out a process on how to solve these equations. So all equations have two sides. You have a left side, and then your equal sign, and then a right side. And equations must stay balanced, and your equal sign is your balancing scale. So in order to keep them balanced, what you do to one side, you've got to do steps to solving an equation. What we're going to do is we're going to simplify each side of the equation as much as possible, meaning we're going to combine like terms or eliminate parentheses by the distributive property and then combine like terms. Whatever it is we need to do to get each side simplified as much as we can, like we did in Chapter 1. We learned all those techniques in Chapter 1. Then what we're going to do is you're going to use addition and subtraction to isolate the variable term on one side and the constant term on the other side. So we're going to start moving things around, and we're going to add the opposite of what you want to move. So in this step, we're doing basically adding the opposite. And then in the very last step, and you're not going to do this until the very last step, you're going to use division to make your coefficient of the variable 1. So again, simplify, and then move things around using addition and subtraction, and then the very last step is to divide. So let's look at this problem on the top left. We have 3x minus 5 is equal to 16. So I see this x term over here on the left-hand side of the equal sign, and I need to get this simplified as much as possible. Well, you can't simplify 3x minus 5, so step number 1 is taken care of. So through addition and subtraction, I want to get this negative 5 over here with this 16. So basically, I want like terms on the same side of the equal sign. So the opposite of negative 5 is a plus 5. On both sides. So we have 3x is equal to 21. So we move things around using addition and subtraction. So now look at what we have. We have terms that are the same on the same side. So in other words, we have all of our x terms on the left side and all of our constants on the right side. Now what I want to do is through division, I want to get this x by itself. So we're going to divide by the number that we want to get rid of, which is the 3. So we're going to divide both sides by 3. And so what's going to happen is that's going to give us a 1x is equal to, and 21 divided by 3 is going to be 7. Okay, the problem on the right hand side, there's no simplifying to do. We cannot combine the negative 4a and the 8, but I need to get like terms on the same side. So I need to get this 8 over here with this negative 5 away from this negative 4a. So I'm going to minus 8 from both sides. And so I have a negative 13 is equal to negative 4a. And now I need to get that a, the coefficient of a, to be 1. So I'm going to divide by exactly what I want to get rid of, which is going to be that negative 4. And so I'm going to have negative divided by negative is positive. So we can have 13/4 is equal to a. Now in your calculator, if you do that division and you come up with 3 and 1/4, that's fine too. It's the same answer. Alright, the last problem here. Notice I have a 2x minus 5 on the left-hand side. So I want to get like terms on the same side. So I need this negative 5 over here with this negative 5. So I'm going to add 5 to both sides. And so we get 2x is equal to 0. And so now I need to get x to go to 1. So we're going to divide by 2. And so we get x is equal to 0. Okay, so this problem on the left, on one side of the equal sign I have 6x plus 4. That's simplified. There's nothing I can do with that. But if you look at the terms on the right, I have a 9x, a plus 4, and a negative 3x. I can combine these two together. So step number 1 does take place here. We're going to simplify this right hand side. So we're just going to bring the left hand side down. And we're going to combine these two like terms. Now, this is where it kind of gets tricky, because if you remember, in order to move something across the equal sign, you have to do the opposite. Again, to move something across the equal sign, you have to do the opposite. But in this particular problem, we're staying on the same side of the equal sign, which means we're going back to chapter 1 and we're just combining like terms. So 9x minus 3x is going to give me 6x plus 4. So then what I'm going to do is I'm going to get my x terms on one side and my non-x terms on the other side. Well, if you kind of look at this problem, you see that you have 6x plus 4 is equal to 6x plus 4, which means that any number that I plug in for x is going to work because these two are identical. But if you don't pick up on that, we can continue working this problem. We can do minus 4 and minus 4, and you see that you're going to get 6x is equal to 6x because the 4's canceled out to 0. And even if you don't see this, you could divide both. Well, I guess you would minus 6x from both sides. And if you do that, you're going to get 0 is equal to 0. So when you come up with a solution that looks like this is a special solution. And when you come up with a true statement like this right here, it doesn't matter what I plug in for x for this equation. I'm going to get the right answer. So actually the answer for this one is x can be equal to all real numbers. Or a way that we can write that is double bar R. Or in your book, you're probably going to see from negative infinity to positive infinity. So that just means that any number from negative infinity to positive infinity, any number I can plug in for x and I would get a true statement. So this is a special solution equation, and you will see one of those, at least one of those, on your test. Okay, on the right here, look at this. There's no simplifying that needs to be done because you can't combine 7m and 5 and you can't combine 7m and negative 3. So what I need to do is I need to get my like terms on the same side. So this time we are adding the opposite because we're going across the equal sign. So if I minus 5 from both sides, we'll have 7m is equal to 7m minus 8. And then to get your m terms on the same side, I would minus 7m from both sides. Well, and this is kind of tricky to see, but remember these are going to cancel out to 0 is equal to, and this is going to be 0 minus 8. So basically what I have is 0 is equal to negative 8. Well, that's a false statement. 0 is never equal to negative 8. So since I get a false statement, this means that there is no solution. In other words, there is no number that I can plug in for x that would make this equation true. Alright, this equation, we have 8n minus 7 is equal to 5n plus 8. So for this equation, there's nothing that I can combine. There's no like terms that I can combine on the same side. So what I need to do is I need to get like terms across the equal sign on the same side. So I'm going to start with this negative 7. So I'm going to add 7 to both sides, but I'm going to add it to its like term. So I have 8n is equal to 5n plus 15. And then I need to move the 5n to the other side. So I'm going to have 3n is equal to 15. Now that I have like terms on the same side, what I need to do is divide. So that's the last step. Divide both sides by 3. And so I'm going to get n is equal to 5. On the right hand side, I have parentheses, so I need to get rid of those parentheses for sure. So what I'm going to do is I'm going to distribute this negative 5 across this group. So the 3x is just going to come down for right now. So what I'm going to do is I'm going to take this whole entire -5 and multiply it times this group. We learned how to do this in chapter 1. So -5 times 2x is -10x. And -5 times 1 is going to be a -5 is equal to 13. Now, let's look on the left-hand side, and you can see that we have some like terms that we can combine. Again, remember, you're staying on the same side of the equal sign. We're not carrying anything across just yet. We're on the same side, so we're combining like we did in chapter 1. So this is -7x minus 5 is equal to 13. Now, step number 1 is done. We can't simplify anymore. So now what I need to do is I need to get like terms on the same side. So I'm going to move this -5 over here with this 13. So since I'm going across the equal sign, I'm going to add 5. This is where I do the opposite. When you're going across the equal sign is when you do the opposite. So -7x is equal to 18. Now I need to get the coefficient to be 1, so I need to divide by -7. And -7 divided by -7 is 1. So I'm going to get x is equal to 18 over -7. And if you get a mixed number, that's fine too. It'd be -2 4/7. Either way. For this problem, there's a lot of simplifying that we need to do. Anytime you see parentheses, you know that you need to get rid of those parentheses first. So let's start doing that. Let's use our distributive property that we learned in chapter 1. So we have -3 times 4n is going to be -12n. And -3 times 2 is going to be -6. And then if we do the distributive property again on this next group, we have a +2 times n, which is +2n. And +2 times -6 is going to be -12. And then on the right hand side of the equal sign, we can do the distributive property here as well. So we have -2 times n, which is -2n, and -2 times 1 is a -2. Now, on the left hand side, there are like terms that I can combine. So I'm going to combine the -12n and the +2n. And when I combine, I'm on the same side, so I'm not adding the opposite. So -12n and +2n is going to be -10n. Then what I'm going to do is I'm going to combine the -6 and the -12. We're on the same side, so we're just combining like terms. -6 and -12 is going to be -18. And on the right hand side, there's nothing to do. Okay, so we've gotten rid of the parentheses, we combine like terms, now we're ready to start moving things across the equal sign. So since we're going to move like terms across the equal sign, this is where we're going to add the opposite. So I'm going to take this -18 over here to this -2. So when I do that, I'm going to add the opposite because I'm going across the equal sign. So I have -10n is equal to -2n plus 16. Now I need to take that -2n over to the left because I need to separate those terms. So I'm going to add 2n to both sides. So we're going to have -8n is equal to 16. So now that I've separated my like terms, I've got my variable term on one side and my constant on the other side. I'm ready to get this coefficient to go to 1, and I'm going to do that through division. So I'm going to divide by -8. So now what I have is n is equal to -2. Another way that we can use equations is to solve real-world problems, and these are going to be application problems, and you're going to see these throughout the semester, and you'll also see them on your final exam. So just be prepared for word problems, because when we do these computational problems, we will do some applied word problems as well, so just be prepared for that. This particular problem says if we subtract 27 from 3 times a certain number, the result is 18. Find the number. So we do have an equation here. I know that I have an equation because it's asking me to solve for the number, find the number. So what I'm going to do is I'm going to turn these words into symbols like we did in chapter 1. So if we subtract 27 from 3 times a certain number. Now this from means that I'm going to take 27 away from 3 times some number. Don't plug a number in, that's going to be a variable. The result, that's going to be equals to 18. So here's your equation for this application problem, and now from here all I have to do is use my techniques to solve for n. So I need to get this negative 27 over here with the 18, so I'm going to add 27 to both sides. So I'm going to have 3n is equal to 45. And now, since I've got the terms separated, I need to get this 3n to go to 1n, so I'm going to do that through division. And so we'll have n is equal to 50. Rate and flat fee. Okay, this is another applied problem. So it says Eric received a car repair bill for $389. This included $159 for parts, $43 per hour for each hour of labor, and $15 for taxes. Find the number of hours of labor. So this is going to be our variable. Hours of labor is going to be our variable. So his total bill is $389. Now, in that $389, it had $159 for parts, plus $43 per hour, and we already said the hour is what we're looking for, the number of hours that he worked, plus $15 in taxes. So there's our equation. If you add all three of these components together, you're going to get $389. Well, the only thing that we don't know is how many hours he worked, and that's going to be our x. So the first thing we're going to do in order to solve this equation is combine like terms. So we need to put that 159 with the 15 together. We're combining like terms. It's on the same side of the equal sign, so don't add the opposite. Just combine like terms. So 159 plus 15 is going to be, I think, 174. And then now that we've got our like terms combined, I'm ready to move my 174 over there to the right hand side with its like term of 389. So since I'm going across the equal sign, I'm going to do the opposite. As long as you stay on the same side of the equal sign, you're going to just combine like terms. But when you go across the equal sign, you got to do the opposite. So we're going to have 43x is equal to 389 minus 174. Which is going to be 215. And then now we can divide both sides by 43. And so we'll get x is equal to 5. So he worked for 5 hours. In order to figure this out, we can plug 5 in for this x and add them up, and we should get 389. Our next applied problem is called consecutive integers, and so we need to talk a little bit about what consecutive integers are, because when you're talking about consecutive integers, you're talking about one right after the other. So consecutive integers means, and this means positive and negative as well, positive and negative whole numbers that occur in order. For example, 1, 2, 3, 4 would be one right after the other, or negative 3, negative 2, negative 1. So we can do positives and negatives. Consecutive even integers or consecutive odd integers differ by 2. So you're counting up by 2's. So for example, you have 2, 4, 6, 8. Or negative 5, negative 3, negative 1, and then even 1. And you can keep going. So to solve a problem about consecutive integers, it's important to set up the variables first. So in this problem, it says find 3 consecutive integers whose sum is 48. So we know that when we add these 3 numbers together, you're going to get 48. So we're going to add 3 numbers together to get 48. Well, Since they're consecutive numbers, we're looking at an example like this, 1, 2, 3, 4, or -3, -2, -1. So we're only going up by 1. So if the first number, if we don't know what the first number is, we're going to let that be n. So if we go to the next number, it would be n plus 1, and then the next number would be n plus 2. Because if we knew what the number was, for example, if we knew that our first number was 3, the next number would be 4, so how do you get there? 3 plus 1 is going to be 4. And then the next number would be 5, so how would you get there? 3 plus 2 is going to give you 5. So that's how we set up a consecutive integer problem. Now we've got to find the three numbers, the three n's. So what we're going to do is we're going to combine our like terms, so we'll have 3n plus 3 is equal to 48. Just combining like terms. Now we need to get this 3 over here to the right, so we're going to minus 3. So we'll have 3n is equal to 45. And then we'll divide both sides by 3. And so we'll get n is equal to 15. So our next number is going to be 16. And then our next number is going to be 17. So there's our three consecutive integers. And on the test, it will ask you to find three consecutive integers. So you need to make sure that you write down three answers. If it asks you to find two consecutive integers, you would write down two numbers, and so on and so forth. Alright, let's look at this problem. It says find four consecutive integers whose sum is negative 118. So again, our first number is going to be n, and we're adding. Sum tells me that we're adding. Our next number is going to be n plus 1, so we have two numbers accounted for. Our next number is going to be n plus 2, so there's three numbers accounted for. And the next number is going to be n plus 3, so there's four numbers accounted for, four consecutive integers, and we have to make them equal to negative 118. So again, on the left hand side, let's combine like terms. So we have 1, 2, 3, 4 n's. And then if we combine our constants, we have 1 and 2, which is 3 plus 3 is going to be 6, is equal to negative 118. So we combine like terms. Now we need to get this plus 6 over here with this negative 118. So we're going to have 4n is equal to negative 124. And then if we divide both sides by 4, we're going to get 1n is equal to negative 31. Well, if we need the next consecutive integer, negative 31 plus 1, and remember we're counting, so if you think of a number line, and this is negative 31, if you're counting on a number line, and you have negative 31, the next number to the right, because you're always counting up, is going to be negative 30, negative 29, and negative 28, because we're getting closer and closer to 0. Also, you know that if we find n plus 1, negative 31 plus 1 is going to be negative 30. So n plus 1 is going to be negative 30, n plus 2 is going to be negative 29, and n plus 3 is going to be negative 28. So be careful when you have those negative numbers. Just remember that you're always counting to the right. In this particular problem, we're still talking about consecutive integers, but this time it's asking for even integers. The sum of three consecutive even integers is 6 less than 2 times the largest of the three even integers. So we're talking about three numbers, but we're talking about even numbers, so we're counting up by 2. So we're going to have the first one's going to be n, the next one's going to be n plus 2, and the next one's going to be n plus 4. Because, for example, if the first even integer is 6, the next even integer is going to be 8. Well, how did you get there? 6 plus 2 is going to be 8. The next one is going to be 10. How did you get there? 6 plus 4 is going to be 10. So this is our setup for our evens, and ironically it's the same setup for our odds, because if it asks for consecutive odd integers, let's pretend that our first odd integer is 5. Well, the next one's going to be 7. How'd you get there? 5 plus 7 is 2, or 5 plus 2 is going to be 7. then the next one is going to be 9. So how did you get there? 5 plus 4, which is going to be 9. So that throws people off. If I'm asking for even integers, you're still going to count up by 2. So if you're asking for odd integers, you're still going to count up by 2. Either way, you're still skip counting by 2. So going back to the problem, the sum of 3 consecutive even integers is 6 less than 2 times the largest of the 3 even integers. So what you're going to have here is the 6 less than 2 times the largest of the 3 even integers. So on the right hand side, because it says the sum of the 3, so we can just add these two, n plus 2 plus n plus 4. The sum of the 3 consecutive even integers is, that's always going to be your equal sign, 6 less than 2 times the larger. So if we do 2 times the larger and then lessen that by 6, that's going to be your right hand side. 6 less than 2 times the largest of the 3 even integers. Alright, on the left hand side we're going to combine like terms. So we're going to have 3n plus 6. And on the right hand side we need to use the distributive property. So we have 2n plus 8 minus 6. And we can still combine like terms on the right hand side. So we have 3n plus 6 is equal to 2n plus 2. Now that I've got everything simplified, I need to start moving things around. So I'm going to get my n's on the same side, so I'm going to minus 2n from both sides. So I'm going to have n plus 6 is equal to 2. And then I need to get the 6 over there with the 2, so we'll minus 6 from both sides. And so we'll have n is equal to negative 4. Well, if n is equal to negative 4, and remember, we're counting up the number line, so if we're at negative 4, the next one's going to be negative 2. And if we keep going, the next one's going to be 0. So your 3 consecutive even integers is negative 4, 2, and 0. 0 is neutral. It can go either way. It can be even or odd, so it doesn't really matter. But if we plug this in, it's saying that the left-hand side, if we add this up, is going to be 2 times n minus 4 minus 6. Well, if we plug these in, on the left-hand side we'll have negative 4 plus negative 2 plus 0 should be equal to 2 times n plus 4 is going to be 0 minus 6. So watch this. Negative 4 and negative 2 and 0 is negative 6. 2 times 0 is 0 minus 6. So it does check out. Alright, so what I would like for you to do is I would like you to try to do these numbers on page 62 and 63. If you have questions, look back in the video or look in your book, as it is an excellent resource. All of the answers to these, since they're odd, are in the back of the book if you need to check your